All right, hello and welcome to this month's Power Hour, where we're going to be talking about crankcase ventilation systems. Really, some of the evolution of it, how they've changed, and some of the diagnostic things we can consider and look at when you have vehicles coming into your shop today that, really anything around the crankcase, the canister purge, the emissions, all these systems are working hand in hand for a lot of different case uses, really to keep fuel economy up, keep emissions down. Well, the crankcase ventilation system has evolved a lot, and there's a lot more that we have to look into today than we used to in the past. So that's our conversation today. I've got Chris in the shop here with me. You've seen him on a couple of past Power Hours here as well. He's going to jump into a couple of things to help me out while I'm back here. And really, we're just looking forward to talking about this system, going over some of the things that we can do to both help our customers, but also help ourselves in the process of diagnostic work and just getting these cars turned in the bay with these systems. So I'm going to head over to the bench. Chris is going to get something set up over here on a Ford F-250, and we'll see you over there. All right, so when we think about modern crankcase ventilation systems, things have changed quite a bit. We've gone away from just having your typical PCV valve. Now this is a little bit more modern by comparison in some of the older styles, but still pretty common when it comes to PCV valves. The reality is this is just one component of many that could be found in a vehicle at this point. We've got systems with 3, 4, 5 different hoses that are going to be part of the crankcase ventilation system. We have vehicles that are going to have pretty substantial breather filters that are going to have to be replaced at different intervals. We also have oil separators. Now some of them can be just flush mounted, pretty simple to take off and remove. Some of these are going to be even harder, and it just depends on the system. We may even have an oil separator that is part of a much more complex system overall. The reality is the PCV, or the crankcase ventilation system, has changed substantially over the years, and that's really what we want to make sure we're all aware of when we have vehicles coming in, one, with emissions related issues or check engine light or rough idle, things like that. It could be any one of these components if we get a code that's going to lead us back to the crankcase system. So that's really why we're here, is to talk about these more modern systems, but we do kind of need to go backwards in time and just kind of look at why we have crankcase ventilation in the first place. And the answer is simple. It's really reducing air pollution and capturing that blow-by. Oddly enough, PCV valves were originally designed for underwater operation, but turns out they have a good bit of extra value to them than just underwater operation. So back in the 1960s, they started using them on vehicles for the simple fact that we've got to reduce air pollution and we need better fuel economy. So you put those things together, it's really going to be beneficial to have a PCV valve. Now the reality is every internal combustion engine is going to experience blow-by, where small amounts of those combustion gases can leak past the piston rings and into the crankcase. We don't want that, because these gases are going to contain a lot of things like unburned hydrocarbons, water vapor, carbon monoxide, nitrogen oxide, oil mist, and even fuel vapor. So if we leave these unchecked, these gases can really do a lot of damage. They can pressurize the crankcase, forcing oil past the seals and gaskets, can contaminate the oil, causing sludge and even acid formation. So, it's going to increase emissions since those gases would otherwise vent to the atmosphere. We want those captured. We want those being vented out. So the PCV system routes these vapors back into the intake tract. It's going to allow the engine to reburn them safely and reduce those emissions. Now, with the early PCV systems, we basically just used a PCV valve to regulate the flow of crankcase vapors back into the intake manifold. Now, fresh air is going to enter into the engine through a breather. It's going to be connected to the air cleaner. And as the engine runs, those blow-by gases are going to enter the crankcase and be routed through that PCV valve into the intake. Now that's where they're going to be burned during just normal combustion. But the valve provides metering to ensure proper flow under different engine operating conditions. Now the basic operation of a traditional PCV valve is really pretty simple. It's spring loaded, it's vacuum controlled, it's got a check valve that's usually going to be housed in either the little piece of plastic or metal like I showed earlier, and it's going to be installed at either a grommet on the valve cover or the intake valve. Now at engine idle, where we're going to have really high manifold vacuum, the vacuum is going to pull the PCV valve's internal plunger or that pintle mostly closed, and it's going to restrict the flow. Now that's going to prevent a large vacuum leak while still allowing a small metered amount of vapor to pass through the intake. Now there's going to be a calibrated orifice in the valve as well that maintains a steady, small flow for those idle conditions. But now when we're at cruise or light loads, we're going to have a moderate level of vacuum where the vacuum decreases slightly and the spring pushes the valve open a little further. Now this is going to allow a greater volume of crankcase vapors to be drawn into the intake for that combustion event. And then we have wide open throttle where, basically we have low or no vacuum. And the spring is going to hold the valve, basically the valve mostly open, and the blow-by is going to be higher under that load, so more vapors can be vented through the valve. But keep in mind, the lack of strong vacuum means that the flow rate is going to remain a little bit limited. But in that, we also have backfire protection. And if a backfire does occur, intake pressure is going to reverse momentarily, and then that valve's pintle snaps shut against its seat, blocking any type of flame or pressure from reaching into the crankcase and preventing possible gasket or seal damage. And now we're going to talk a little more about the evolution of some of the PCV systems or the crankcase systems, but even in the latter years, from the standard PCV valve up to, the current modern systems, in between we've had some evolution, and one of those evolutions was heated PCV valves. So we could have this done either electronically or we could even have it done with coolant passing through it. But this was just one of the earlier evolutions in the PCV system, because we do have climates and places up north and the Midwest, things like that, that are going to have much colder temperatures, and we don't want these to freeze shut. So the adoption of those heated PCV valves was one of the first kind of evolutionary things to kind of come into the system before we got to some of the components I showed you at the beginning here, which is a vast evolution of crankcase systems versus what we had in the very beginning, and even with the heated PCV valves. But whether it was the older style PCV or even some of the heated ones, back in the the early days of PCV, we actually had a little bit easier time diagnosing these systems. There was really a couple of faults that would come in. We didn't see it on the dash. We got it from the driver. The driver told us, hey, I've got a rough idle, or I seem to be using a lot of oil. I'm putting a quart of oil in every month, but I don't see it on my driveway, so where's it going? Well, in some cases, if we pull that breather hose, we're going to find oil in the hose, and now we know we have a restriction somewhere. That PCV valve is not doing its job. And so, it was really a lot easier to diagnose. Didn't mean it was easy, but it was a little bit easier to diagnose just based on some visual inspection things. And because of that, it kind of turned into part of a routine maintenance item. So you have a vehicle come in, it's just doing your typical tune-up, spark plugs, wires, cap, rotor, things like that. Well, it was recommended at that time to go ahead and do a PCV valve as well. Think about it, we're going to have it firing better, we're going to have it running better, we're going to have it breathing better. Let's make sure all of those components are in there at the same time. So it was just a common replacement item, and they were so inexpensive that back then it was just a few dollars added to the ticket. Customer didn't mind, and they felt the difference when they drove. Well, that's just not the case anymore, right? We have totally different systems, modern systems, we have diesel systems out there. It's all changed a little bit, and sometimes a visual inspection just isn't going to be enough. And I just mentioned diesel because we obviously cannot avoid crankcase systems when it comes to diesel. Now with diesel, they're going to be considered a CCV, a closed crankcase ventilation system, and that system is going to reroute the crankcase vapors back into the engine intake airflow. Now the vapors are going to be directed into a replaceable filter that's usually mounted underneath the cylinder head cover, and then that filter is going to redirect oil droplets back into the crankcase. Now the remaining vapors are going to pass through the filter, and those are going to be directed into the intake airstream and the front of the turbocharger inlet. And in this example here, we can see we're talking about a 6.7 Cummins, and it's pretty simple. We remove the cylinder head cover or the valve cover, and underneath that, we're going to find that breather filter. But I think it is important to note that the cylinder head cover has an integral valve called the CDR, which is the crankcase depression regulator. Now that's going to meter the crankcase vapors that are coming into the intake system. Now that CDR valve is going to allow the system to maintain a constant positive pressure within the crankcase, and it's going to use a sensor to monitor that pressure on the intake side of the CDR. Now, as that system ages, that filter is going to become restricted. It's going to get clogged, and it's going to require replacement. Here's the big deal though. If the filter becomes too restricted, Under a high vacuum situation, basically that crankcase system prevents the engine from siphoning crankcase vapors, into the engine. And so that filter replacement is just part of the regular schedule of maintenance for this particular vehicle. And the filter is scheduled, technically supposed to be replaced every 67,500 miles, but I think we know most people don't do their maintenance on time. And even if they did, let's say they were doing it every 67,500 miles like it says, well, let's take into account vehicles like Hotshot. We have Cummins engines out there on 2,500 and 3,500 Rams that are putting 200,000 miles a year on the chassis of that vehicle, just running hot shots one side to the other. Well, in a situation like that, if we've got a higher mileage or a constant mileage vehicle that's just moving and moving at all times and quickly adding those miles up, this is one of those spots where we may recommend to the driver of that vehicle, like, hey, I know it's a little more expensive to maintain this more so than what's recommended, but on a vehicle like that, around 40, 50, even 35,000 miles is something you might recommend for somebody like that. If it's your typical 15 to 30,000 miles a year on the road, let's stick with the regular service interval. But if we have someone putting a lot of miles on one of these types of engines, we really want to recommend doing that filter as often as possible. And moving past that conversation around the breather filter there on that Dodge Cummins, there are other applications that are similar, but can have their own quirks as well. And just to give you an idea of that, we actually have an F250, a 6.7 liter Power Stroke diesel here in the shop. Chris is over there, we've got the hood up, and he's gonna show us a little something here, something he's ran into a few times, and maybe something you can be on the lookout for if you have one of these come in. So Chris, if you don't mind, just kind of run through what you're trying to show us here.
Yeah, thanks, Corey. So yeah, as we just talked about, this filter, the crankcase ventilation filter, or sometimes called an oil separator, depending on the vehicle. This example right here is a perfect location though of, we can see this under the hood, easily accessible. This isn't just a component that sits under here, we don't have to do anything with it. This is actually a maintenance item on a diesel engine, and a lot of the time it's an overlooked maintenance item too. This crankcase filter on this application is a new enough F250 where this is a serviceable element internal to this, whereas earlier versions, if you've replaced some of those, it actually was an entire unit. They've actually updated that sometimes, and we've even had to update the PCM just to match that filter that we're placing in the vehicle. Now, some reasons why we'll replace this, not only because it's a filter element that needs to be replaced, if we're not breathing out the crankcase ventilation properly and we're kind of stopping up the flow, well, what we can have is actually leaks caused by not replacing this filter. So if you've ever seen some of the Power Strokes, we may run into a leaking oil pan gasket. This would be a prime example of where we're going to want to check on replacing this filter to either prevent that, or if we're doing that and replacing the oil pan gasket, let's make sure we take care of the filter at the same time so we don't have a comeback after replacing that. So that's kind of our tech tip on this product line here. And with that, Corey, I'll send it back to you.
All right, well, thank you, Chris. And yeah, so I mean, that's really just a quick blip when it comes to crankcase systems for diesels, but we really wanted to hone in on those filters because it really can make or break or be the difference in the drivability of some of these diesel trucks that are out there. So just a quick blip again on the diesel side, and really just a quick rundown of the older style PCV systems, but we really want to talk about some of the more modern systems now, things that you're going to see coming into your shop, things like the separators and some of the new hoses and stuff like that. Why are they within the system? Well, we have to think about what's out there now. So historically, for domestic engines, the PCV systems have been pretty simple, trouble-free. We basically forgot about them for a long time. But you take into account things like the LUV engine, which is going to be a European-style closed PCV system. The crankcase is essentially sealed, and the PRV is going to be used to manage crankcase pressure so that it stays between that -3 to 7 in H2O. So when the pressure rises above that level, the PRV opens and vents pressure to the one-way valve in the intake manifold. Now, if the manifold pressure is below baro, then the crankcase gases will flow into the intake manifold. But if the manifold pressure is above that baro, when we see boost present, then the crankcase gases are going to be diverted to another one-way valve at basically the turbo inlet where they are going to be ingested. And if we take a little closer look at that PRV, notice the various forces that are being applied to the valve. Now, a spring is going to provide an upward force and attempt to fully open the passage between the crankcase and the intake manifold. The hole in the top of the PRV is going to apply atmospheric pressure to apply downward pressure on that spring and restrict the passage. And then we have crankcase pressure that's going to exert an upward force on the valve, attempting to open the passage even further. And then manifold vacuum with a one-way valve open where we don't have boost present is going to exert pressure that attempts to restrict the passage. So the movement and the position of the valve opening is going to really be determined by the combining of these forces. What are we asking from the vehicle as we're going down the road? And now I talked a little bit about, some of the ways that we could diagnose some of the earlier PCV systems. It was fairly simple. There was a couple of quick visual things that we could do. We don't get that as much anymore. We'll look at something here in a minute that maybe you can get a little bit of a visual inspection, but in a lot of cases, we may just have a check engine light and we have to go through a series of steps, to diagnose what the customer complaint is. But the nice thing is we do have that now. We do have a lot of specific codes that are going to be related to the crankcase system. So you see it here, we've got a 2195 or a 2197 where we have that lack of, HO2 switching. We've got a lean bank 1 or 2. We even have a code for an air leak between the throttle body and the intake valve, which is kind of nice. So it gives us a little bit more insight or an idea of where we can kind of move to as we're diagnosing these systems. And just as another example, here's a 2022 F-150 with quite a few specific codes just for that vehicle. That one, we also see that throttle body intake valve code there as well. But we have some very specific codes that are going to be related to that particular vehicle. So it is kind of nice, and this is where we would really recommend doing as much as you can in service information to understand what some of these codes mean, and maybe look for TSBs. Maybe there's something out there that is related to this, and there are definitely a lot of TSBs around Ford when it comes to some of these systems. So my recommendation would always be check TSBs and service information before we start tearing something apart, because there's a really good chance that one thing begot another thing, and you're going to need more than just what you think that you need, or you may not even need anything at all. Maybe something that is a quick fix or a quick turnaround. Again, there's so many TSBs out there around these systems. Always check that. But one of the reasons I say that is because I've done this myself, and here's the example. Now, on a 2013 Ford Escape 1.6 turbo, we use this vehicle a lot, and the reason we use this as an example a lot is because they gave us gold with this car. This particular first year of the engine in that particular model, first body style of that model, we're going to have gold with something like that. And this one was not a letdown when it came to that. There are so many repairs related to these 1.6 turbos, and so many TSBs and so many things that really technicians can't stand about that vehicle, which a lot of it comes down to what you see on the screen here, time. It takes time to get to some of these components. And we're bringing that up for a very specific reason here, which is if we look at this one, we're going to have to remove the intake manifold. Now, if we do that, we're also going to have to remove the starter. And maybe you can get away with it, maybe you can't. If you've worked on these a lot, you have the specialty toolkit to lock that crank, or not the crank, but the flywheel, and make sure there's no rotation. So maybe you have to do that, maybe you don't. But the reality is on this vehicle, if you're going to replace just the valve, then it's going to take you upwards of 6 hours to get in there and get it all done. You're also now going to have to buy some intake manifold gaskets. Depending on how much you have to take off, it could take a lot of work, a lot of time, and require some extra components. So we bring that up for this reason to say, when you look at this screen, you'll see the oil separator is there as well. If this were a 100,000 mile vehicle and I already had to put 6 hours into it to take the manifold off, remove the starter, lock that flywheel in place, I'm going to try to go ahead and do that separator as well. Maybe even the hose. If I can get the entire unit in one piece, that's what I want. I don't want to do this work twice. I don't want to replace the valve only to find out 30 days later that the separator it's either clogged or something's wrong with it. That's the last thing we want to deal with. So we talk about this for the very specific reason of, if you're going to have to take a whole lot of stuff apart, look and see what can be replaced at the same time. These crankcase systems, again, are fail items. Every one of these components are going to fail at some point. If we're already in there and there's 3 components side by side, it's probably a good idea just to get them all put in at the same time. Save yourself a headache, save yourself a comeback, and honestly, you're really doing a good job for your customer and making sure that when they take it back out on the road, they know that crankcase system is working properly 100% of the time. And so in saying that, not every vehicle is the same. Yeah, it might take 6 hours or 8 hour amount of time to access certain components on certain vehicles like this Escape here, where, just to get to a component, we have to remove another major component like an intake manifold. And we don't want to do that. If we're not 100% sure, that's our problem, because now we've got to consider intake gaskets, any other gaskets that are removed, possibly stripping bolts. There's a lot of things that can go wrong tearing something apart that we haven't really put enough diagnosis work into. So always good to go as far as you can before you disassemble. But in some cases, even on some of the newer vehicles like 2015s, Chrysler, for example, there are some cases where we have really relatively easy access in order to, maybe it's Swaptronics, maybe it's this or that, but we have access. And for that, I'm actually going to send it over to Chris here. We've got I think it's a 2015 Chrysler 200, and he's going to go over some of the components on this particular vehicle to kind of give a drastic comparison, right? 6 hours on an Escape versus how long you think on this, Chris? I'll let you take it away.
Yeah, thanks, Corey. Yeah, as you just stated, right, every vehicle is going to be different. We've got a few examples today. We've already covered the Escape. We're going to go over this Chrysler, all very different systems. This application here, all I've done so far is just take off the hush cover over top of the engine bay. So we've removed the engine cover off, the insulating cover, and if you look at this vacuum hose right here, this vacuum hose actually goes directly to the PCV valve. If I take this off or if I unbolt the PCV valve, I've already got direct access to the PCV. This is just our typical PCV valve that we've probably replaced years past already on older applications. Very similar valve on this vehicle as well. But to Corey's point though, we do want to make sure that not all vehicles are the same of, yes, I'm lucky here. We can get to that valve easily. Now, if we've got that Ford Escape example, I'm really going to want to be sure that I'm on the right path. Even on this vehicle here, we can kind of do ourselves a favor and go through a diagnostic path looking at the scan tool. And so we're going to actually look at some scan data on this and see what's some applicable data for it. All right, we're going to set the scan tool on the bench here, and we are going to look through some of the data here. A lot of this isn't going to be applicable, and like I said, sometimes we're going to have really good data. We may have a pressure sensor on the crankcase system where it'll actually give us live data right off of that component itself. And so with that, we can go through, try to find some information on if we've got crankcase pressure, if we have intake pressure as well. So is our vacuum drawing down far enough? Are our fuel trims okay? So those are some of the really key PIDs I'd be looking at, are various fuel trims, and especially at different loads too. So we may have a failing PCV valve on a vehicle like this, and if we've got a weak spring, at times we may be bleeding off vacuum or drawing on the crankcase and vice versa. And if we're going to try to diagnose that, we can catch it in scan data, but again, depending on the vehicle application. This vehicle would be an example where we may be best served because we have such good access and because it's a rather simple valve. Well, maybe I'm best off to remove it here. In the case of that Ford Escape, that's not what we're going to be looking at. We're going to try to get as much scan data as possible. And luckily, most of the applications though do give us a lot of usable information to try to diagnose that system. So don't put this on the back burner. Let's try to look at the scan tool first for some usable data, and then we can go into physical removal of parts if need be.
And I couldn't agree with you more there, Chris. The last thing I want to do is tear stuff apart that I find out later I didn't have to, but lo and behold, I probably broke something in the process. Yeah. And I don't want to deal with that.
Exactly.
So great call out there. Thank you, Chris. I appreciate you helping us out today. And so like Chris was saying, there's actually quite a bit we can do, even on visual inspection or, some quick data PIDs that we can pull up. There's a lot we can do to try to diagnose these systems without tearing everything apart. There's even, systems where we can just measure that crankcase pressure. And so when we look at, that was a Chrysler 200, we've looked at the 250, the F250, looked at an Escape, but if we move on to a 2021 Buick Encore here, this engine itself is also going to use a PRV to manage crankcase pressure. And so here, we're actually using a pressure transducer. We've removed the dipstick, and we've actually plugged in to basically check that crank pressure or the crankcase pressure while at idle. So we're going to measure it with that pressure transducer at idle. And so again, this is another way that we can do a quick diagnostic and figure out what that pressure looks like before we go digging too much into pulling parts off. And when we do a process like that, we can get a pretty good piece of information. We've got our picoscope or whatever lab scope that we're using hooked up. You can see here with the oil cap installed and the crankcase sealed, that PRV is maintaining that -3 in H2O in the crankcase. But as soon as we pull that oil cap off, we remove it, that pressure changes to +3. So something as simple as hooking up a pressure transducer and a pico really quick and just doing that pressure test can give us a lot of diagnostic information on how that system is either pressurizing or not pressurizing, depending on what the situation is in that specific vehicle. And so thinking about that pressure test, just remember, a crankcase leak actually means that pressure is entering the crankcase from the outside. And in any kind of leak, any crankcase leak of any kind is going to affect fuel trims more aggressively than open, fresh air systems. So just keep that in mind when you're doing some of this diagnostic work. So let's put some of this together and look at a case study real quick that kind of might open some of our eyes to some of the things we may be running into in the near future. If you haven't seen this yet, I promise you're going to see this, and it's probably going to be more often than you would really appreciate. But it's great for service. It's great for vehicles coming in. So let's look at this 2015 Buick Encore. Again, it's got the LUV, the turbocharged engine. It's the 1.4 liter. And I think we're all shocked at the mileage there, 109,896 miles on this motor. I don't know if it's the original motor or not, but if it is, that's pretty impressive. So we look at this and we've got the customer complaint that comes in. Really, the concern was that the MIL was on, right? So we've got that on, and they said it ran just a little bit rough. Okay, so we're going to do our typical work order. We're going to look through the process. We're going to go do a visual inspection. And when we do this, oftentimes we're not going to see anything immediate. Some of these systems are so sealed up and also part of other components that a visual inspection is not really going to do us any good, but we're going to do it anyway because that's what we always do, right? We do a visual inspection. Well, that didn't give us anything, so we'll do a quick pre-scan, and sure enough, there was just one code in that ECM, the P0171, where we have a fuel trim system lean. So at least we had a code that gives us a little bit of an idea of where to start looking. And so our technician is going to throw a lab scope on here, and we're going to start graphing some information. We're going to look and see what we can find just off of a quick graph. So while recording that scan data, right, we're going to go on a test drive, we're going to get the picoscope set up, and we're going to record some scan data. And while the vehicle was out, it mostly ran fine. But now and then, it did have a slight hesitation. Now, take a moment here to look over the graph here, right? So at idle, our short-term fuel trim was 18%, and our long-term was 33%, which is indicating to us a pretty massive lean correction. Now, under light load, fuel trim values were normal, with a short-term fuel trim of -1% and a long-term value of -3% at the cursor. So, that's good to know, good piece of information. And so in this case, we're kind of getting conflicting information, right? It runs one way at, top speed or, cruising down the road, and it runs another way just sitting at idle. So of course, we're going to have to do a little bit more further analysis, further inspection. And that's when the technician takes it back into the service bay. And with the engine idling there, closer to the engine himself, he heard the more common fault that we find with these, which was a hissing noise coming from that PRV, that pressure regulating valve, which, is kind of in a bad spot. You can't do anything about it. It's right there on top, but it's a sealed piece. Now we can hear the hissing, but there's really no way to get in there and find out if there's anything wrong with that PRV without actually tearing things apart. And remember, on this style, we have crankcase gases that are reaching the intake manifold through the cylinder head where they flow to the internal one-way valve, which we've got it kind of circled there. And the port near the one-way valve is then connected to the turbo inlet. Now we've got one cut away here just a little bit so you can see that little orange diaphragm in there. Now obviously, you can't see that when you're doing a visual inspection, but we wanted to show you exactly what that looks like within that system. One note here, you can actually go and look at this through GM. I can't remember if it's a TSB or just a quick service bulletin on there that's basically saying you don't have to tear this apart the way that you see it here. If you actually look through that tube where the hose connects, if you take a light and you flash it in there, just another little tip here, if you see a conical shape in there, you're good. Typically speaking, when these diaphragms go out, the conical shape will be gone because the diaphragm will be gone. So if you can get a light in there and see that that diaphragm is still, that conical shape is still in there, you should be good to go. If it's missing, that's another piece of the diagnostic that we may want to be looking into. Is it the intake manifold? Did that diaphragm go bad? Well, in this case, it did not. We see that it's still there, but just something to point out. And then moving on from that, we have another point of failure that could go bad, which is the hose that's going to connect the intake manifold to the turbo inlet. Now remember, the one-way valve at the turbo is integrated into this hose, right? So we've got multiple things that could be going on here. We've got a PRV valve that could be an issue. We've got a hose that might be an issue. We may have an intake manifold. We know the hose and the intake manifold are not the problem because we have the conical shape and we don't have any noise or any type of leaks coming from the hoses. So let's go look at that PRV. Now, when we want to look a little further into the PRV valve, again, we can't always see through a visual inspection what's going on with the diaphragm, what's going on with the spring. There are some systems that are a little bit easier with visual inspection, but a lot of these components are sealed. They're in a tight bound component, and there's really no way to actually see them. We're lucky on the one side with the intake manifold where we might be able to put a light in there and see that conical shape. But in the case of this PRV valve on this particular vehicle, it's a sealed unit. But we want to point this out, which is even a small tear in that PRV valve diaphragm can be enough to, one, cause that hissing sound, but also cause that conflicting information that we're getting on that graph. So in some cases, it may require some disassembly, to determine what the actual issue is. Now, this is a pretty hard case here. We don't need you to pull a valve cover off and, destroy the top of the PRV valve cover and only to find out that it's not bad. But if you did have one that was a fail, that it was a fail and you replaced it, it fixed the problem, maybe this is something you could at least show your customer, hey, this is why we had to replace this. Probably doesn't need to be going through all that work to prove that, but at the same time, this is a pretty common fault. So, the technician's thinking, I know it's not the manifold, the hose looks good. I'm thinking it might be that diaphragm because that technician has run into this before. So we're going to do some more graphing. We're going to do some more data, scope data, and look at some things. So if we look, at the data from the test drive in the context of how the PRV operates. So now we're looking specifically at the operation of the PRV. At the cursor, we can see the engine is at part throttle, around 1600 RPMs. That total fuel trim is very close to 0% despite a torn PRV diaphragm, which we found out later was definitely the case. And then the baro is 28, while the manifold pressure is higher at 34.5 due to boosting from the turbo. This means really that the intake one-way valve is working and closed, so trim is not being affected. Now, if we use the data from that previous capture and add a math channel that indicates the status of the manifold one-way valve based on the baro and map pressures, you can see there when trim is very high, shown here at the cursor, the manifold one-way valve is basically wide open. So the technician kind of thought about it and said, you know what? I thought it was the PRV. I'm going to go ahead and replace this valve cover. and see what happens. And of course they were right. They went through the steps, they went through the process to try and verify everything prior to just throwing a part at it. And in this case, yes, it was a common fault. It's a pretty common issue. We could probably just throw it at it and that would probably be the fix. But at the end of the day, there's a lot of things we can do to, verify a diagnostic on these crankcase ventilation systems. Even if it is something that's pretty common, you're going to run into this 9 out of 10 times. Well, that one time might be the hose. That one time might be the intake manifold. So let's make sure we go through and look at all of the components within the system and use that scan data or that pico data or that lab scope data to give us an idea of how things are working hand in hand and really look at some of those fuel trims and get a better idea of where it's probably leading to. All right, so in the spirit of time, I know that's a whole lot of information really fast. And again, we could get really deep in the weeds on diesel crankcase ventilation, really deep in the weeds on modern crankcase ventilation, even deep in the weeds in some of the older style PCV systems. But the reality is what we want to really convey here is they've changed, they have evolved, and it's going to take a good bit of diagnostic procedure sometimes to find the fix for a vehicle that you're having a problem with. So really, our summary and what I would suggest is try to replace components as a system. And so if we think back at that Ford Escape example, if we're going to replace the hose or the PCV, let's go ahead and replace the oil separator at the same time. It just makes sense. We're already in there, possibly running 6 hours. Don't overlook filters during maintenance. Again, depending on what kind of vehicle it is, it could be diesel, it could be gasoline. If we have a breather filter of any kind that's within the system, it's always good to recommend that to the driver, the actual owner of the vehicle, that it's something that they may want to consider because, again, the better we breathe, the better we run, right? And that's just really how it goes. And then, replace components when accessible, whether as a system or accessible. Again, if you do that 6-hour job, let's just do whatever's down there and get done with it. That way we don't have to, worry about it come back in 15, 20, 30 days. And remember to always test PRV and check valves if you can. If there's a way you can test it, whether manually or just going through scan and graph data, try to test that PRV first, because chances are that's going to be either the problem itself or it's going to lead you to the problem. Because, again, it's I wouldn't say a new system, but it's the evolution of the crankcase ventilation system. And it's one of the more common reasons that we have faults. We have check engine lights and we have, rough idles and poor driving conditions. Now, before we go, I do want to recommend, don't forget, go to Standard Brand on YouTube. We've got hundreds of videos there. We have our past power hours there. And, a lot of great content on not only just the product itself, but in some cases, installation procedures, in other cases, quick tips on specific engines, specific vehicles, even specific parts. So there's a lot of resources there on our YouTube channel at Standard Brand. And also don't forget about the website, standardbrand.com, where you can actually look all of these components up. Essentially, if you're working on a vehicle that has a crankcase ventilation system in it, if we have a part for it available, you're going to find it right here, along with other resources, in regards to information around the category or the component, or maybe even updates around the category or component. And you can also, from here on the training tab, get yourself registered for next year's upcoming power hours, and then also the last one for the year here in December. All right, and so before we go, I do want to address one question that came through here. You could do it one way, you can do it a million ways. It depends on how you want to get your diagnostic work done. But the question came up is, can we still use smoke machines when it comes to this type of system? I would say absolutely, yeah. If you can hook up a smoke machine, close that system off, and let's take an example of that, that escape. Maybe we've got a leak at the hose, or maybe we've got a leak from the hose to the connector of a separator, something like that. There's a really good chance a smoke machine will help with that. Really anything with canister purge, emissions related, crankcase ventilation, if you can get that smoke machine hooked up, close that system off, there is always going to be a good chance that you may be able to find a leak. Now, it may not work with that PRV valve that's in that valve cover. simply because it's a sealed system, and unless the gaskets on the valve cover are messed up, you're probably not going to see that smoke come out from around the valve cover itself. But there are a lot of components where a smoke machine could be helpful. So with that, in the spirit of time, I know we've been here a little while. I want to thank everyone for being here. Thank you for joining us, and we hope to see you next month on December's Power Hour, and then again next year when we start back up again. Have a great day, everybody. Thanks again.